Recently, event cameras have demonstrated their potential in robust 3D hand pose estimation for scenes with fast motions and broad dynamic range. In this work, we propose EvHandPose, a novel weakly supervised framework for event-based monocular 3D hand pose estimation on sparse labeled event streams. Experiments on our real-world dataset EvRealHands demonstrate that our method outperforms the recent event-based methods in all scenes of testing set and RGB-based method in challenging scenarios. EvHandPose can achieve accurate high FPS hand pose estimation. Here we show 120 FPS results. Fast motion will lead to severe hand motion blur effect of RGB camera. However, the asynchronous imaging nature of the event camera allows it to capture microsecond motion information, and EvHandPose adopts motion representations to record the hand movement precisely, thus achieving stable high FPS inference. In our work, we summarize the challenges of event-based methods and propose the corresponding solutions. Estimating hand poses using events faces three key challenges. First, asynchronous event streams are spatially sparse and temporally dense, so existing image-based solutions cannot be directly applied to events. Moreover, event cameras suffer from the motion ambiguity issue, since the static hand parts cannot generate events. Second, for annotators, they could only provide sparsely annotated hand poses by sampling the keyframes along the temporal dimension. The third challenge is that the existing method suffers from domain gap between synthetic and real data. To address the above challenges, first, we design specific hand flow representations to alleviate the motion ambiguity issue. Second, we apply contrast maximization and edge constraints in a weakly supervision framework to tackle the sparse annotation issue. Finally, to address the domain gap issue, we construct EvRealHands, the first large-scale real event-based hand pose dataset under various challenging scenarios. In this chapter, we introduce our method, EvHandPose. EvHandPose pipeline consists of two main parts, event-to-pose module and pose-to-IDUE module. The event-to-pose module is designed to predict hand pose from the event stream. After fusing the edge feature and shapeflow, this module recurrently regress hand pose. The pose-to-IDUE module is then designed to supervise event-to-pose module during training. We calculate the mesh flow by feeding two sequential ManoMeshes into mesh flow layer and warp the events to get the IDUE. For weakly supervision, we adopt contrast maximization and edge losses. In supervision method, the model can only learn hand poses at annotated timestamps, and the interval of each event subsegment has to be strictly overlapped with the annotated period. In weakly supervision method, we only need partial labels, and the outputs of unlabeled subsegments are constrained by weakly supervision loss. Therefore, EvHandPose can learn hand poses at any timestamp near the annotations with dynamic time window. In this chapter, we introduce the dataset EvRealHands. EvRealHands is captured by a multi-camera system, consists of 7 RGB and an event camera. EvRealHands is collected under normal lightning scenarios and challenging scenarios such as strong light, flash, and fast motion. For annotation, we use a two-stage process consisting of machine annotation and human annotation. For fast motion sequences, we manually annotate the 2D joints on the event sequences. For various hand gestures, we collect 3 sequences for each hand, which consists of 15 predefined hand poses, about 20s shown in here, and random hand poses, about 80s. We mainly show qualitative experiments results in this video. For quantitative analysis, please refer to our paper. In normal scenes, our method outperforms EvHandPose because our method leverages the temporal and spatial features of events effectively and addresses the issues of motion ambiguity and sparse annotations. MobRecon works better than our approach in normal scenes due to the richer texture features and higher spatial resolutions of RGB images. In fast motion sequences, EvHandPose outperforms EvHandPose and MobRecon with lower 2D MPJPE. EvHandPose can achieve 120 FPS or higher hand pose estimation and output smooth, high-time resolution hand pose sequences. This is not only due to the imaging nature of event camera, but also due to our effective motion representations. EvHandPose predicts more accurate hand poses than MobRecon on strong light sequences. EvHandPose can generalize well to strong light scenes and extract efficient edge and hand flow feature, thus achieving robust 3D hand pose estimation. In outdoor, EvHandPose shows more robust hand pose estimation under strong light and fast motion scenes, which derives from the stable motion representation from outdoor event sequences and weekly supervision framework. When directly testing the models on another type of event camera prophecy, our methods show better generalization than event hands. Our motion representation can extract shared motion clues among different event cameras. Although EvHandPose shows promising performance, we find that there are still several failure cases. First, motion ambiguity issue. It is still challenging to predict the pose of a static hand. Second, new pose. Random poses has greater diversity, leading to a slightly performance drop. Third, flash scenes. A large amount of noisy events will erupt if the scene has broad dynamic range. Thanks for your watching.